Welcome to our class in normal distribution. So normal distribution, basically, we will learn how to use a standard normal distribution table. So normal distribution has a number of properties that you need to understand. And these properties are essential to know because you will be guided as the rules to abide by. So whenever a question to do with normal distribution is given, it will be mentioned succinctly that this follows a normal distribution. So there are a number of properties that a normal distribution will have. And they are number one, symmetry. So by symmetry, we mean the left side is equal to the right side, or the right side mirrors the left side. So there are four key properties of a normal distribution. Of course, there are 10, but I'll dominate on only 4. So if you're dealing with a normal distribution, you will discover that on the left side will mirror the right side. So here there's 0.5, and here there's another 0.5. So collectively, the area under graph is equal to 1. So that means they are symmetrical. So the other property of normal distribution is that it is bell-shaped. Bell-shaped simply means that it looks like this. It's bell-shaped. It looks like a hill. Okay. The other property is that it is unimodal. Unimodal means that it has one single peak. It is not like this. It only has one single peak. Then also, it is parameterized by the mean and the standard deviation. So our mean is always here in the middle, and our standard deviation is given there. So that's why the normal distribution will be given in terms of what? Mu stroke standard deviation. So the mean is actually the center of the distribution, while the standard deviation controls the spread. If you have a bigger spread like this, meaning the standard deviation is bigger. If the height, which is the kurtosis, is small, meaning the risk, the spread is small. Okay, so these are some of the properties of a normal distribution. Of course, there are several others, just for your own knowledge, that I can simply add on. Properties of may include the empirical rule. So according to the empirical rule, the normal distribution will allow the empirical rule to apply for the following percentages: 68, 95, and 99.7%. So the empirical rule simply approximates the percentage that falls within the standard deviations as follows. So if we have one standard deviation, so this is 0 and this is 1. So meaning the percentage under this graph here, there's 1 there, -1. This is equivalent to 68%. Then if the distribution goes to 2, here there's 1 and there's 2. The area under graph here increases from 98% to 95%. If the distribution is what? 3, area, I have 3, and here there's 3, meaning here the area, the probability under this graph is equivalent to what? 99.7%. So this is another property. It follows what we call the empirical rule. The other property that normal distribution will have is that it extends from a negative infinite to a positive infinite. So it doesn't touch the base. It doesn't touch the base. So these are the key properties of normal distribution. Okay. Any questions so far? All right, so we now go to the principles. Now, there are two tables that I'll give you, but before we go to the tables, you need to understand that the word greater means what? Shade to the right. The word less means what? Shade to the left. So diagrams that look with a greater parameter are these ones here. So this is greater. This is also greater. Except that this greater is more than 50%. It's 50% plus because it's a big region, whereas this one is less than 50%, so 50% minus. All right. So that is the difference between these two shading. On the other hand, less than means what? Shade to the left. So if we're shading the left, we're going to the left direction. So this one here is a small shading. It means that the reading should be 50% or less. And this is also less than, except that we're starting from the right to the left, it's going to the left. So this is a big shading, so it is 50% plus. So under normal distribution, we have what we call the standardization formula, which is equal to Z X minus mu over standard deviation. If you're given a sample size, this formula will just slightly change to be X minus mu over standard deviation square root of n. Now, under probability distributions, this is the toughest topic, so I need you to pay extra attention. Okay. So let's now go to the table and how to read it. So we have an X-ray of statisticians here. These figures should be interpreted by you. Now, these areas under this normal table typify the readings under the graph. So if I ask you to give me the reading for 1.23, you go under 1.2, which is this one here, and under 0.03 here, where they meet. So what is the reading? 1.23 is 0.89065. So what does that mean? It means that ideally the reading of from here to here, 1.23, we already know that this reading here is 50%. Okay. And the reading from here, the beginning up to this point here, according to our table, what is the reading? We found the reading to be 0.89065. So 89065. Now, some of the tables are cumulative, others are non-cumulative. Others will just show you just this area here, from here to here. Obviously, when you remove the 50%, it will give you 0.39065. So I need you to really pay particular attention depending on the table that you're using, because this is where most of you may get it wrong. So how do we know which table it is to use? There's a cumulative and the non-cumulative table. So if you're looking at the cumulative table, just your hint, you discover that on the positive side, you always see that these figures are all more than 50%. You've noticed? So it is a standard normal cumulative table. But we also have a half table where you're going to see the figures here all less than what? All less than 50%. But the readings are basically the same. For instance, if I asked you to give me the reading for 1.07, 1.07. So we go under 1.0, then under 7. What reading do we have? 1.0, then under 7. What reading do we have? 0. What? 3577. Do you see? 0.3577. However, the other table, even if we haven't checked, it will only add a 50% here. So meaning the reading there on that table will be what? 0.8577. So don't get confused. They're the same tables, but the treatment is different. So let's check on the other table. 1.07. What is our reading? 1.0 under 7. So you see, we get 0.8577 or 8569. This one has more digits than the other. So it's the same figure that you're getting, 0.8577. Even this one is 0.8577. The other one is rounded off. Okay. Now, there are also negative readings that you'll find in that table, whose reading also start from the start. We can call this a start. So if I ask you to find the reading of what? -1. So -1. So the reading that you're going to have is from 0, or from the start. It's not 0, 0 is in the middle, from the start to -1. So when you check here, from the start to -1, so what is -1? -1 is on this other page. So -1.0. So this is the reading for -1. So 15,866. So the reading here means from here to here is 0.what? 15,866. All right. That means that from here to here, the percentage is 15%. Now the question, however, is if I go to this other reading, how do I find the 15%? Because all the readings here are coming from exactly the middle. So when you're going to go to this half table, it will give you 0.3413. Why is it so? Because the reading from the half table starts from the middle line. It doesn't start from the edge. All right. So the 0 point, you're going to have 0 point. So the difference in this one is that the reading from here to here, that is giving you 0.3411 what? All the readings from the half table, they come from the middle. So you're 0.3413. So this means that to get this small reading here, we're going to subtract not 1, because this whole half table, this side is what? 50%. So we're going to subtract 0.5 minus 0.3414. So which will give you 0.1587. That is how this is done. Okay. Any questions so far? I really want you to understand the two tables because sometimes people get confused. Now, like I said, this is the toughest topic, so I need you to understand it very fully. So if you're given to find the Z of 1.34, Z of 2.0, Z of 1.67, and finally Z of -1.33. Can somebody help me? What is the Z for 1.34? Can you check in here? Z for 1.34? need to exercise your skills. 1.34, what is a Z? What is a Z for 1.34?
Hello?
Yes, please.
I think it's 90988.
So you go under 1.3.
1.3.
Look at 1.34, right? So you go under 1.3, yes.
Where it intersects.
With what?
With the 0.4, which is 90988.
Correct. So that is how we find the reading here. So the reading will actually be 90988, 0.90988. All right. So who else wants to try to find the reading for 2.0? What is the reading for 2.0 on the table? I hope you all also have these tables individually. 2.0, what is the reading under 2.0? Anyone else? Ronnie?
It's 0.97725.
97725, correct. All right, so now this is a normal way of reading. When you're reading the table from outside to inside, there are certain times where you'll be required to read from inside to outside. So you need to locate the table. For instance, if I ask you, what is the probability, the p-value of this one? So 89065, we just add 1.2 and 0.03. Collectively, this is 1.23. If I ask you what is the Z value of this probability, 90988, just add the 1.3 and 0.04, so we have 1.34. But sometimes you may not have the exact figure. For instance, they ask you to find 0.991110, 0.99110. You can still qualify this one because it's the closest possible. So what's the reading for 0.99111? What is the reading for this figure? What is the Z value for 991110? 0 point. So you get the figure this side, 2.3, and the figure above 7. So our final figure will be what? 2.77. Right together. Now, the application of these tables now comes here. You'll be given a scenario question to say, suppose the mean is 10, the standard deviation is 3. Find the probability that X is greater than 13. So we're going to use my own formula called ISA. ISA acronyms: illustrate, shade, standardize, and apply. So using our table, we know that the mean is always in the middle here, and the mean is equivalent to 0. Then 13 is on the right side of 10. If I had a 6, I'd have put on the left side of 10. So step 2, we've been asked to shade. So illustrate, shade. Step 3, standardize. This 13 I need to standardize. So Z is equal to X minus mean over standard deviation. So here it will be 13 minus 10 over 3. So this will give you my Z, which is 1. So 1. So the reading from here to here is what I'm going to get in the table. So when I go to 1 or 1.0, it's going to give me 0.84134. 0.84134. meaning the reading from here to here is about 84%. So for me to get the reading that is remaining, it's just a remainder. So I'm going to subtract 0.84134. So meaning the remainder here will be about 15%, 0.1587. Now suppose I was using another table. What do? Do I still subtract from 1? So you need to be very careful. Of course, it's a standard table that you're given. But in the event that you have a different type of table, like this one here, it is a half table. When I go to 1.0, the answer I'm going to get is 0.3413. What do? And what's the meaning of that? 0.3413, 3413. So that reading simply means that it's only accounting for this part here. So it's only accounting for this part here. So meaning this reading is 0.3413. So for me to get the remainder, I'm going to subtract 0.5 minus 0.3413. So when I compute this one, I'm still going to get the same value, which is 1584. So you need not to get confused by the table that you're using at any particular point. Suppose we're asked to say the mean is 10, the standard deviation is the same 3, and you're asked to find probability that x is less than 16. Less means what? Shade to the left. So illustrate. The 10 is here, 16 is there, then shade. We're going to shade this side. Already, the shading is big. What is the principle? Whenever the shading is big, we read it directly. So we standardize. What we standardize? Z is equal to x minus mu over standard deviation. So here we have 16 minus 10 over 3. So it is 6 over 3, which is equal to 2. So here Z is equivalent to 2. So when you check inside the table, the reading for 2, in here, it will give you 0.4772. But if you go to this other table, when you read under 2, it is 0.9772 or 25. So the reading from here to here is 0.9772. The other table will just give you 0.4772. For the half table, since it's just giving you the reading from here to here, just add it to 0.5 because this one is 50%. But for you guys using the full table, just read it directly. Don't subtract from 1 because it makes sense that the whole area here is about 97%. All right. So are we together? Yeah, especially for you, because this is what your homework, everything was correct except you're using a different table. But I was very impressed with how you articulated it. Okay, so now, sometimes they'll give you a funny question to say, find x for which we are 2% greater. Okay, given our mu is what? Same 10, and our standard deviation is same 3. So greater is 2%. So whenever you're given a percentage, you're being taught how to read from inside the table. So our 10 is here, then our 2%, when you remove the 2%, because you're removing from the right side because of the weight greater, the remainder to remain here, the percentage is 98%, because 0.800. So you need to check for this percentage inside the table, the 98%. So when you go into the table, like I said, if you don't find the exact, you find the nearest possible. Which one is nearer? 98%. It is this one here. No, not that one. It's actually this one here. This one is 80.03. This one is 97.98. So it's this one is more by 3 points, this one is less by 2 points. So we pick the closest possible, which is this one. So 2.05. So our Z is 2.05. So we know that Z is equal to what? X minus mean over standard deviation. So because of the 2% here, we are going to say 2.05. And our X is what? What we're looking for. Our mean is 10 and our standard deviation is 3. And you cross multiply. 3 times 2.05 is equal to X minus 10. So when this one comes here to add 10 plus 3 and 2.05. The final answer is the value of X. Final answer is the value of X. Now, are there any questions? This question came as follows. Instead of the word greater, they decide to use less than. What happens? We're going to shade on the left side. Okay. If they said less than, we're going to shade on the left side. So the only difference that we're going to have here is that the 2% will come from here. What will remain here is 98%. And 98% when you check it from inside the table is what? Negative 2.05. We're using negative because it's on the left side. So everything else will work out except that on the Z can be negative, but probability you can't get a negative. So 2.05 is equal to 10 plus for X minus what? 10 over standard deviation, which is the 3. So let me take you to an exam type question and see how the questions come. I've shared this revision kit with you. And this will be your homework. So let me just quickly guide you through from what I've taught you. So we're given a question, for instance, say a soft drink vending machine is set to discharge an average of what? 215 with a standard deviation of 10 mils. So what are we given? Average means what? Mean. So our mean is 215, and our standard deviation is what? 10. So part A, you're asked to find the probability if 225 cups are used, what's the probability of an overflow? So overflow is synonymous to what? Greater. So greater than 225. So using ESA, step 1, illustrate, shade, and apply. So here our mean will be in the middle. Our mean is what? 215. And 225 is here. We'll put the divider, 225. Then why are we using greater? Because the word we're using there is overflow. So step 1, illustrate. Step 2, shade. Step 3, standardize. So these 215, what is it in terms of Z? We know that the mean is always 0 in terms of Z. So to standardize that, we say Z is equal to what? Mean minus standard deviation over mean minus X minus mean over standard deviation. So 225 minus 215 divided by our mean of 10. So 225 minus 215 is 10. So 10 out of 10 is 1. So this is equivalent to 1. Now the reading from here to here is for 1, but what we're interested in is a small reading. So using the application, whenever the reading is small, we subtract from 1. You remember? So let's read and find out the reading for 1. What is the reading for 1? Some of these things you can memorize because we've been talking about 1, 2, these are very common numbers. All right, so 1, You can, if you're not sure, just go to the table and find out. So 1.0 is 84,134. 84,134. So this simply means that the reading from here, 0.84,134. That is the reading from here to here. However, the small reading that is remaining is simply going to subtract 1 minus 0.84,134. So this is simply the difference in our area under graph. So any questions so far?
So it was so if it means if it's like you're shedding a bigger region, it means it remains like that.
Yes, if it's a bigger region. Excellent. So now,
A small region.
correct. Let's do it quick. Can you remember? I'll shed 4 regions. Tell me 2 things about them and the application thereof. So there's region A, region B, region C, and region D. So I'll start by mentioning region A, the 2 things that I need you to take note of. So region A denotes greater. This is going to the right, it's a greater than number 1. Now region A also has a small region. So the answer that we're going to get, we subtract from 1 if you're using the cumulative table, or we subtract from 0.5 if you're using the half table. So that's what I can say. Who can use the same format to explain region B or figure B? What is happening in figure B?
Figure B is less than,
Good.
and then
Figure B is going to the left, so it's less than. What else?
it's a small shaded region.
The shaded region is small. Therefore,
you subtract from 1.
yes,
Or
we subtract from 1 the reading, the p-value, or we subtract from 0.5 depending on the table that we're using. Correct. How about region C? Region C is showing you less than. What's going to the left? However, the region is what? It's greater. It's big. The region is big. So the region is big. We either read directly as it is, or there's half table, you add a 0.5. Region C is going to the right. It is greater. Coincidentally, even the region is a big region. So we read it directly from the table or add a 0.5. All right. So is that clear? That's why I called it what? Apply. That's where the application comes from. So lastly, from the question example that we are looking at, we are also told to say a soft drink vending machine is allowed to discharge food drink. What is the probability that it contains at least 200 ml of food drink? Right? At least means that number and above. So we know that our mean is where? 215. Then it says at least 200. So 200 will be here. We'll put our divider there. So it's going to shade this side. So already our mean is here in the middle 0. So we standardize is 200. 200, even if we don't know what figure is there, it should be negative because it's on the left side of 0. So 200 minus 15 is what? 15. 15 divided by 10 is negative 1.5. So you're going to read from the table the reading for 1.5. So the reading for 1.5, when we find it, are we going to read it as it is, or we're going to subtract? Anyone? The reading, are we going to subtract or read direct? 1.5. Direct, correct. Why? So 1.5 here is 93319. So because the shading is big, so this one is starting from here to here. All right, 933. Okay, 15. So this region is big. There's no way we could what? Subtract 13319. There's no way we could subtract from 1 unless we're looking for this small region. Then lastly, what size of caps ought to be used if it's desirable that only 2% will overflow? So overflow is like on the greater side. So the 2%, we remove it. So meaning we're going to remain with 98%. In decimal, this is the same as 0.91800. And I taught you how to read from inside the table. We're looking for X, we don't know. Our mean here is at 0. Our standard deviation is what? 10. So 0.9800, when you go into the table, you find it under 2.05. We did a similar question. So 2.05 because of the 2%. So the closest is what? This one here, 2.05. It's closer than this one, 98, and this is 97.9. So that's why I got the 2.05 reading from inside the table. So here Z is what? 2.05. So using Z is equal to what? X minus mu over standard deviation. Right. So here we're going to have our X we are looking for. Here we're going to have 215. And here we're going to look at our standard deviation, which is 10. Then cross multiply. That's how you find the value of X. Are there any questions?
I have a question. Let's say instead of using the full table, the half, you said half table, right?
Yes. If you're given the half table, the 2%, you subtract it from 50%, not from 1. So meaning you're going to say 50% minus 2%, which is 48%. So we go to the half table. Let's see whether it's also equal to 2.05. So the half table should reflect what is there in the full table. So the half table, 2.05. Except that I don't have the full half table.
0.0.
Yeah, you have it. What is it saying?
0.0202.
So when you check inside the half table, it will still give you the closest figure will be somewhere 0.3. It will still be at 2.05 because the closest figures are at go to be there with 0.4798 if you're going to check, because it will be 4798 because it's just remove a 5 from there. So it's the same thing, but the closest under 48% will be 47.98. All right. That is how it goes. Any questions at that point? Anyone with a question? Do you get that?
Yes.
Yeah. Right. So I'll send the recording. We have another class at 20:30 today. We'll cover the empirical, the Chebyshev rule, and the other probabilities like binomial. Thank you so much.